So here. So here, today's topic is about the organometallic compounds. So in this, what is the classification of organometallic compounds and what are the uses of organometallic compounds? How we can prepare organometallic compounds? Okay, this topic is discussed in this class. Let us see first introduction. The metallic derivatives of carbon compounds in which the metal ion is directly bonded to the carbon of the compound or the group are known as organometallic compounds. The metallic derivatives of carbon compounds in which the metal ion is linked through oxygen, nitrogen, sulfur, etc. are not known as organometallics. For example, tetraethyl lead, it is an organometallic compound, but the sodium methoxide, it is not an organic compound. Let us see here in this. So one metal atom is directly bonded with the carbon. Those are called as organometallic compound. For example, lead, it is the metal atom. It is directly bonded with the C2H5 taken 4 times. So the lead metal is directly bonded with the carbon. So it is called as organometallic compound. Then next, if we can take the another one, that is C2, wait a minute. C2H5ONa. So this is the oxygen atom. So this is the ethyl group. In this is the carbon. The carbon is not directly bonded with the metal. So here the sodium metal is bonded with the oxygen. Then only the oxygen is bonded with the carbon. So this type of components are not called as OMC. Understood? The metal atom is directly bonded with the carbon. Then only those are called as OMC compound. The metal atoms are bonded with inorganic molecules, then bonded with the carbon. Those are not considered as the OMC compounds. Next is look at this. The classification of organometallic compounds. Okay. The organometallic compounds are classified as simple and mixed. Organometallic compounds are mainly classified into simple organometallic compounds and mixed organometallic compounds. Okay. The organometallic compounds in which the metal atom is linked to alkyl group only, those are linked to the alkyl groups of hydrogen atom are collectively called simple compounds. Okay. Which are called as simple OMC. The metal atom is directly bonded with the carbon compounds. Those are called as simple OMC. Let us take C2H5 taken 4 times, lead C2 H5 taken twice. A simple group of carbon containing compound is bonded with the metal. Those are called as simple organometallic compounds. Okay. Then next, another one is that the organometallic compound in which the metal is linked to alkyl group as well as to other groups. The best example is that C2, H5, Mg, Br. Okay. So in this is the alkyl group, this is the metal. So this alkyl metal combination, one halogen group also there. So these are mixing properties present. So this type of substances are called as mixed organometallic compounds. Okay, only the metal atom is bonded with the carbon compounds. It is called as simple OMC. Then the metal atom is bonded with the carbon and non-metallic compounds. Those are called as mixed OMC compounds. So this is one classification. The next is about the types of organometallic compounds. So the types is explained based upon the nature of the bond. It is explained to 4 types: ionic OMC, sigma bonded OMC, pi covalent OMC, and the last one is bridged bonded compounds. Which one is called as ionic organometallics? Highly positive metal atom forms this type of compounds because the metal atom is having the positive charge and the alkyl group is having negative charge. The metal is having the positive charge and the carbon compound, these are called the alkyl group, is having the negative charge. So due to the attractions between the metal and carbon, a bond is formed. This type of OMC is called as ionic OMC. Okay. Then next, the better example is that C6, H5 taken twice, Na plus. So the sodium is having the positive charge, carbon is having the negative charge, and bond is formed in between the OMC. This OMC is called as ionic OMC. Okay. Then let us take sigma bonded OMC. So which are called as sigma bonded OMC? The organometallic compounds formed by non-transition metals. Okay. Non-transition elements are mostly this type only. These are formed by low electron positive metals. The bond formed between the carbon and metal is sigma. Okay. Bond is formed in between the metal and carbon is sigma. Those are called as sigma covalent compounds or sigma bonded compounds. That means the bond strength of metal and carbon depends upon the carbon compound part. Here we can take CH3 taken twice, SnCl2. Cl. Okay. In this, a sigma bond takes place in between the metal and the carbon compound. So this type of compounds are called as sigma bonded OMC compounds. Next is regarding that pi bonded OMC. So the pi bonded OMC, we can explain it by a sandwich structure. The ferrocene is the best example for this type of components. Suppose we can take cyclopentadienyl ring. So this is, let us see. This is one cyclopentadiene ring. it is bonded with the iron and it is bonded with the, so this two cyclopenta, so this is one cyclopentadienyl ring, this is one cyclopentadienyl ring. So these two rings are sandwiched by the iron. Then this type of components are called as pi bonded organometallic compounds. So this type of compounds are called as pi bonded organometallic compounds. Okay. The next one is bridged organometallic compounds. So the example is that, so this is the aluminum metal ligand, aluminum metal. This is aluminum metal. This is one alkyl group. This is one alkyl group. This is another alkyl groups. Here, look at this. In this two, this alkyl group is bridged in between the two aluminum. This is also this alkyl group and this alkyl group. Both are produce a bridge in between the two alkyl aluminum groups metal. So that's why this type of OMC is called as aluminum OMC. So this type of OMC is called as bridged OMC components. Okay. Then next topic is about the preparation of organometallic compounds. How we can prepare organometallic compounds. So the first method is that direct method. In this direct method, the metal atom is reacted with any aryl halide. Okay. The metal atom is reacted with any aryl halide. The metal atom, sorry, it is magnesium. This magnesium metal is directly bonded with the aryl halide. So this magnesium is directly linked to this aryl halide. Those type of reaction preparation methods are called as direct reaction with the metal. Okay. Then the second method is that in this second method, by mutual exchange of the metals and halogens. Look at this. In this, we can take the C6H5Cl benzoyl chloride, sorry, phenyl chloride. This phenyl chloride is reacted with the butyl lithium. Okay. Then it is converted to phenyl lithium C6H5Li plus C4H9Cl. So this method is called as mutual exchange of metal and halogen. So this metal is reacted with the lithium and this alkyl group. This alkyl group is reacted with the metal and it is converted to phenyl lithium. And this alkyl group is reacted with the chlorine and it is converted to this structure. So the mutual exchange of the ligand, mutual exchange of the metal atom and the ligand is takes place. So that's why it is called as mutual exchange of metal and ligand. The third preparation method is that the mutual exchange of hydrogen and metal. Mutual exchange of mercury and metal. Look at this. So this is dialkyl mercury. It is reacted with the lithium metal. Then it is converted to alkyl lithium and mercury. So the mercury is exchanged and the lithium is added. Okay. Instead of the mercury, we can take the lithium. If we can take instead of the Hg, we can take the H also, RH. It is nothing but alkane. Alkane is reacted with the lithium, then the hydrogen is eliminated, then it is converted to RLi. Okay, this type of reaction also takes place. Okay, understood? 3 types of preparation methods are there. The first preparation method is by direct reaction with the metal. The metal atom is directly react with the aryl halide, alkyl halide. It is converted to OMC compound. The second preparation method is that the mutual exchange of the metal and halogen. We can take the halogen compound as well as metal compound. Halogen with alkyl group, metal with alkyl group. Alkyl group with halogen is replaced by the lithium component. So that is mutual exchanges takes place in between the metal as well as the halogen. Next is by mutual exchange of mercury and the metal. The mercury and the metals are exchanged. So this is called as mutual exchange of metal and mercury. Then the next one is that a special applications of lithium, magnesium, and carbon compounds. So what are the special applications? So the first one is that preparation of hydrocarbons. If we can take any OMC compound, that OMC compound is undergoes hydrolysis, then it is converted to alkane. For example, in this reaction, we can take this one, that is methyl lithium. Methyl lithium undergoes hydrolysis. Look at this, how the mechanism takes place. CH3 Li, it is undergoes hydrolysis and it produces the product. So in this CH3 Li, it is converted to CH3 minus plus Li plus. This H2O is converted to ionized to H plus and OH minus. So this H plus is added to the methyl group, then it is converted to CH3 plus H. It is converted to CH4. And this is linked, hydroxy group is linked with the lithium, then it is converted to lithium hydroxide. Okay, this is one preparation method. Understood? The alkyl, the metal alkyl is reacted with water and it is converted to alkane. The next preparation method, it is preparation of alcohols. Preparation of alcohols with Grignard reagent. Okay. So when you just remember that the carbonyl compounds, aldehydes or ketones are reacted with the Grignard reagent, they can produce the primary alcohol, secondary alcohol, tertiary alcohols. So first, when the formaldehyde is reacted with the Grignard reagent, what is a Grignard reagent? That is RMgX. R is nothing but alkyl Mg, magnesium alkyl, magnesium halide. Okay. Alkyl magnesium halide is called as Grignard reagent. So, if we can take any formaldehyde, okay, the formaldehyde is reacted with the RMGX, then it produce the primary alcohols. Okay, RMGX is reacted with formaldehyde. The structure of formaldehyde should be like this. Okay, then it produce the primary alcohols. If this RMGX, it is reacted with the any aldehyde, then it produce secondary alcohol. If this RMGX is reacted with the ketone, it produce the tertiary alcohol. Okay. The RMGX Grignard reagent is reacted with the formaldehyde. It produces the primary alcohol. Then RMGX is reacted with second acetaldehyde. That is nothing but aldehyde. It produces the secondary alcohol. RMGX is reacted with the ketone. It produces the tertiary alcohol. Already in this slide, the perfect explanation is there. Look at this. So here in this, first we can take the formaldehyde. It is reacted with RMGX, then it produces unstable structure. It undergoes hydrolysis and produces the primary alcohol. How the mechanism takes place. So in this reaction, first we can take the formaldehyde. In this formaldehyde, the carbon and oxygen is having the double bond. The oxygen atom is more electronegative. Due to that reason, the pi bonded electrons are shifted over the oxygen atom. Then oxygen get the negative charge and the carbon get the positive charge. Then it halide. It is converted to ionized to R minus and M. Reacted to positive charged carbocation and MgX is bonded with the product. This unstable product, when it is involved in the oxygen magnesium sigma bond is electrons are transferred towards the oxygen atom, because when comparing with the electronegativity, the oxygen atom is more electronegative than the magnesium. So that's why the sigma bonded electrons are shifted to the oxygen atom. Then carbon get the negative charge and magnesium halide get the positive charge. When it is involved in the hydrolysis, H plus and OH minus ions are produced. The H plus is attached to O minus, then alcohol is formed as the product. So this alcohol is called as primary alcohol or CH2OH. Then the second one is that we can take any aldehyde. That aldehyde is reacted with the alkyl magnesium iodide. Then it produces unstable product. The unstable is involved in the hydrolysis. It produces the alcohol. Okay. So here in this reaction, we can take the aldehyde. In this aldehyde, the carbon oxygen double bonded electrons are polarized to oxygen atom. Then oxygen get the negative charge and carbon get the positive charge. Then it is reacted with the RMGX. It is converted to R minus and MgX plus. The R minus is added to positive charged carbocation and MgX is bonded with the oxygen atom. Then an unstable product is produced. Whenever it is undergoes hydrolysis, the proton is added to the O minus and OH is added to the magnesium iodide, then it is converted to secondary alcohol. So this is the structure of secondary alcohol. The last one is that if we can take the ketone, ketone is reacted with alkyl magnesium iodide, then they produce unstable product. It undergoes hydrolysis, produce the tertiary alcohol. Look at this. In this structure, ketone, the carbon oxygen pi bonded electrons are polarized toward the oxygen atom. Then oxygen get the negative charge, then carbon get the positive charge. Then it is reacted with the alkyl magnesium halide. It is converted to R minus and NGX plus. The R minus carbon ion is added with the carbocation and O minus is bonded with magnesium iodide. This type of unstable structure intermediate is produced. This intermediate is involved in the hydrolysis. Then H plus is added to oxygen atom and OH is added to magnesium iodide. Then it produced a tertiary alcohol like this structure. Okay, this is regarding for the preparation of primary, secondary, tertiary alcohol. Next, third preparation method is that preparation of ethenes. Ethenes also or esters also prepared by using this techniques. Here, the monochloroethers react with the alkyl metal. They give higher ethers. Look at this. We can take monochloroethers ROCH2Cl. Okay, it is called as monochloroether. This monochloroether, it is reacted with the alkyl metal and it produces more number of carbon containing ether, that is ROCH2. Instead of this chlorine, R group is substituted and the metal is reacted with chlorine, then it is converted to NCl. So in this only one alkyl group and one CH2 group is present. In this two are alkyl groups and one CH2 is present. When comparing with the reactant, in the product, the more number of alkyl groups are there. So that's why by using this method, we can prepare the more number of alkyls containing ether component should be prepared. Next preparation method is that preparation of alkyl cyanide. So in this process, we can prepare the alkyl cyanide. How we can prepare? Let us take the reaction. So this is Cl. Cn is called as cyanogen chloride. It is reacted with OMC. Then the alkyl group is added to the cyano group. Then it is converted to alkyl cyanide. And the metal atom is bonded with the chlorine. Then it is converted to NCl. Okay. So in this preparation method, we can prepare the alkyl cyanide. Next preparation method is that preparation of amines. Amines also prepared by using the OMC. RM is nothing but OMC. RM, it is reacted with chloramine. ClNH2 is called as chloramine. Then the NH2 is bonded with the alkyl group. Metal is bonded with the chloro group. Then it is produced amine product. The next preparation method is that preparation of thyroalcohols. Okay. or thioalcohols should be prepared. Thio means the sulfur group is called as thio group. Okay. The OMC is reacted with the sulfur to give thio components, thioalcohols. This on hydrolysis gives thioalcohols. So here we can take the OMC. RM is nothing but OMC that is reacted with sulfur. Then it produced alkyl thiometal. This is undergoes hydrolysis. Then it is converted to RSH. RSH is called as thioalcohols. Then the next preparation method is that the preparation of either other organometallic compounds. So if we can take one OMC, by using this one OMC that is reacted with another molecule and produce the different OMC compound. For example, AuBr3, RM bromide, it is reacted with OMC. Then this in RM is nothing but OMC. In that, the alkyl group is reacted with RM and it is converted to alkyl RM. Cadmium chloride, cadmium metal, it is reacted with RM, it is converted to RC. That means alkyl cadmium, just like alkyl silicon components also prepared. Then next take another different types of reaction, that is carbon monoxide. Carbon monoxide, carbon dioxide is reacted with alkyl lithium. Then it produced a structure. Then it undergoes hydrolysis. Finally, it is converted to ketone-like structure because in a complex, before formation of the ketone, a structure is there. In the two hydroxy groups are present. When the two hydroxy groups are attached to a single carbon, it is unstable. Due to formation of stability, two OH groups, it eliminates the water molecule and convert it to keto compounds. Okay. Then the next reaction is that, so this is the another reaction, and the pyridine also reacted with the phenyl lithium. The phenyl hydroxide is and hydrogen is eliminated. Then the phenyl ring is attached to the pyridine. This is another preparation method. The next one is that use of organometallic compounds. So what are the uses of organometallic compounds? The organometallic compounds find wide applications in synthetic organic chemistry. Of these compounds, Grignard reagent occupy a special place beside these organometallic finding different applications. Okay, so generally the organometallic compounds are having the special properties. In this alkyl magnesium halide, it is having a specific character because by using that Grignard reagent, we can prepare the primary alcohol, secondary alcohols, as well as tertiary alcohols. Then the second application is that the tetraethyl lead was used as anti-knock in petrol, but nowadays it was banned. Then in the synthesis of polymer components also, we can take the OMC component. For example, butadiene. In butadiene preparation, we can take the butyl sodium, it is converted to butyl sodium bunarapur. Alkene is reacted with alkyl lithium, then it is converted to alkyl lithium elastomer is prepared. Then ethylene is reacted with the triethyl aluminum, then it produced a polymeric components. Okay, in the polymer components also, the OMC are very useful. The first one is that if we can take the butyl sodium, it is reacted with butadiene, it is converted to butyl sodium bunarapur. The second application of polymer is that if we can take the alkyl lithium, this alkyl lithium is reacted with alkene and it produces the alkyl lithium elastomers. Then triethyl aluminum, it is reacted with ethylene, it is converted to a polymer product. Next, tin, aluminum, boron, carbon compounds are used as fungicides. And that means in the industry, in the agriculture process also, we can use these OMC components. Then arsenic, strontium, bismuth, mercury, lead compounds are used as war gases. That means in the war also we can take the OMC components. Okay. Up to this, the today's topic is completed. Then continue tomorrow. Thank you.